Let us see how group 15 elements reacts with hydrogen. Nitrogen forms ammonia with hydrogen. Phosphorus forms phosphine. Arsenic forms arsine. Antimony forms SbH3, and bismuth forms BiH3 with hydrogen. So this was reactivity with hydrogen. Now, how the properties of these hydrides vary? Down the group, the hydrides have decreasing melting points. Down the group, the melting point decreases. Like for ammonia, melting point is 195.2 in terms of Kelvin. For pH3, it is 139.5 Kelvin. For arsenic, for arsenic hydride it is 156.7 Kelvin. For antimony hydride, it increases little bit. So these values we don't have to remember, we have to just see what happens to the trend of the melting point. That if you take melting point as the trend, then how does it vary? So since we know that this is 185, so this is an exception. So in this case, first of all we will write in the order of melting point. If we arrange these compounds in the order of their melting point, then it would be like this. First ammonia, then hydride of antimony, then hydride of arsenic, and then hydride of phosphine. Similarly, there is variation in their boiling point also, and it is not regular. Like if this was melting point, then for boiling point it is like for ammonia 238.5, for phosphine 185.5. These all are in Kelvin. 210.6 Kelvin, 254.6 Kelvin, and for hydride of bismuth it is 290. Now let us see again. As we are going down the group, in general the boiling point is increasing. See, it is maximum, and this is minimum. So first of all it decreases, again it increases, and then increases. So the order is not uniform. So there is a variation in the trend of physical properties. So for boiling point we can write maximum boiling point will be of bismuth hydride, then antimony hydride, then ammonia, then arsenic hydride, and least is of phosphine. So these values, if you remember individually, as much you will be able to remember, that much you will be able to answer questions based on the order of variation in the trends. So there is no fixed order. These values are observed values, and all the explanations are based on what is observed. It is not because what we explain due to which these properties are there. These properties are experimentally seen, which are further expressed by some theories. Mostly chemical properties are asked, and these are data based questions. If you have a data, then you will be able to answer. Certain trade based questions are like why bismuth hydride is the strongest reducing agent amongst all other hydrides. Say if the question is why bismuth hydride is the strongest reducing agent among all other hydrides of the same group. Then we have to think in the line of the question, that what explanation we can find to relate the fact which is given in the question. Reducing agent would be a compound which can give out hydrogen atom very easily. Now, which molecule can give out hydrogen atom very easily? The molecule in which the bond between the metal and the hydrogen is weaker. Now, since we know that hydrides, hydrogen and nitrogen, phosphorus, these are comparable, they have comparable electronegativity, so their covalent bond is stronger. But as we are going down the group, metallic property is increasing. As a result, the bond dissociation energy between the metal and the hydrogen atom decreases. So if the hydrogen is liberated easily, then we know that the liberated hydrogen will reduce any other compound which is in the form of oxide, because addition of hydrogen is also called as reduction. So how can we answer this question? We can answer like this. Down the group, with increase in the metallic property of p block elements, the bond dissociation energy of p block element bonded with hydrogen decreases. So BiH3 can give out hydrogen atom more easily than other elements. Hence BiH3 has highest reducing ability, or we can write strongest for this. Another question could be, what is the order of basicity of hydrides of group 15? So here we have to understand the meaning of basicity. The word basicity means basic character, means ability to accept H plus, ability to accept H plus. As we know that nitrogen is most electronegative element, so it can accept H plus more easily as compared to phosphine, then as compared to arsenic hydride, or as compared to antimony hydride, and as compared to bismuth hydride. See, ammonia, it has a tendency to accept H plus, but these elements, as you go from this to this, you will find that they have the property of giving out H minus hydrides. And they have got very less tendency of accepting H plus, since the central metal ion like bismuth, they are metallic in nature, so they don't prefer to accept H plus, rather they prefer to give out H minus. So they have high reducing ability and low basicity. They don't prefer to take H plus. Rather they prefer to give out hydride. Hence, hydrides are stronger reducing agent towards down the group, and they have low basicity towards down the group. Now we will be discussing about the reaction of p block elements with that of oxygen. Reaction of p block elements or group 15 elements with oxygen. Say if E is any group 15 element, then the type of oxide formed by it could be E2O3 and E2O5. Let us take the example of nitrogen. Nitrogen shows anomalous property, so it forms 5 different types of oxides. It forms NO, it forms N2O3, it forms N2O5, it forms NO2, it forms N2O. So apart from these 2 types of oxides, other 3 types are also possible in case of nitrogen. But in case of phosphorus, it forms either P2O3 or P2O5, which further exists as P4O10. Another thing to remember here is that oxides of nitrogen and phosphorus are acidic oxides because they are non-metals, because nitrogen and phosphorus are non-metals. But if you will compare the oxide of antimony oxide or arsenic or bismuth oxide, then since they are either amphoteric or metallic, so they are either amphoteric or basic. So these two are amphoteric that means they show the property of both acid and base, and bismuth oxide shows basic property, basic oxide. This shows acidic oxide, amphoteric oxide. The reason is because non-metallic oxides form acidic oxides and metallic oxides form basic oxides. But if the element is less metallic or like metalloid, then they form amphoteric oxide. Amphoteric oxides are the oxides which shows the property of both acids and bases. Now we will see the reaction of group 15 elements with halogens. reaction of group 15 elements with halogens. Nitrogen can form NCl3, NF3 very easily, but it cannot form NCl5. This is not possible. The reason of this was discussed earlier. It is because nitrogen has (2p3) configuration, wherein there is no d orbital where this electron can go and get unpaired. So there is no d orbital available. Hence, nitrogen cannot extend its covalency more than -3 or +3. Like for NH3 it is -3, and if you take NF3 it will be +3. But for rest of the elements like phosphorus, can form PCl3, can form PCl5 because it can extend its covalency. Now we will see the reactivity of group 15 elements with metals. Reaction of group 15 elements with metals. So if E is equal to any group 15 element, Then element of group 15 element with metals forms binary compound. Means compounds containing two atoms or two types of atoms in which E exhibits E minus 3 valency, such that calcium nitride is formed, sodium arsenide is formed, zinc antimonide is formed, magnesium bismuthide is formed, how do we name them? We name them like this. Ca3N2 is called as calcium nitride. The suffix "ide" is used when there is no oxygen in the anion. Na3As is sodium arsenide. The N3sB2 is called as zinc antimonide. And magnesium bismuthide is Mg3Bi2. This is named as magnesium bismuthide. Let us see a few questions. Question 1. Though nitrogen exhibits +5 oxidation state in HNO3, it does not form PCl5. Oh, sorry, it does not form NCl5. Give reason. So answer is in HNO3 nitrogen is showing +5 oxidation state. But for NCl5 to be formed, pentacovalency is needed, not +5 oxidation state, as nitrogen has no d orbital, so in NH2NP3 configuration, NH2 electron cannot take part in sp3d hybridization. Second is pH3 has lower boiling point than NH3Y. pH3 has lower boiling point than NH3 because nitrogen is more electronegative than phosphorus. So hydrogen bonding so hydrogen bonding between NH3 molecules are stronger than that of pH3 molecule. Therefore, pH3 has lower boiling point than NH3.